on 1.4, what was the endpoint of RQ? R, right? R is your endpoint because it's the point on the end. Good. All right, angles can describe a location. So make sure that you name them correctly, and we're going to talk about naming them in just a minute. The degree is the way that angles are measured. All right, so degrees, the angle that a unit is measured, or the angles are measured, and angles where two rays have a common endpoint. So an angle is made up of two rays. Got me? However, you know, we talked about the other day that you have a straight angle or opposite rays. Remember those? And that is called a straight angle, and that is not considered an angle because it makes 180 degrees. Right? If it makes straight up both ways, you don't consider it an angle because it's 180 degrees. You just consider it a straight line. All right? Vertex is the common endpoint. It's where the two rays intersect. Okay? Where the two rays intersect. Ray SR, ray ST. They intersect at point S. There's only one point named S, and that is the vertex. And when you name a vertex, you name it like you would a point, capital letter. All right, sides. Sides are rays that are that make up the angle. So if I name the side, this is name the side of the angle, I would name it the ray ST. Is there another side of the angle? SR. And what kind of SR is it? It's a ray. Good. The vertex is just a common point, a capital letter. That's it. You only have one of them. Is that all right? To name an angle, there are three possible ways, all right, and sometimes a fourth, depending on what the angle looks like, but three possible ways. You can use the vertex and a point from each side. The vertex has to be in the middle. You've got to have this symbol. That symbol, kind of slanted L, means angle. So I know when we have 3 points, you're talking about an angle, not a plane, not a triangle, talking about an angle. An angle. Okay, the vertex has to be in the center. All right, and then a point from each side of the rays. So S and T. Or you could have done this, angle TRS. Either one of those two setups, angle SRT or angle TRS. R is in the middle. Why is R in the middle in this picture? Because it's the vertex. The vertex has to be in the middle. That's what lets me know where we start. We're starting at one of these sides. We get to the common point, and we go to the other side. Okay, we can use the vertex only, and that is sometimes, right? Sometimes beside this. Okay, only sometimes. I can name it by, what's the vertex? R, thank you. I can name it by the vertex. The only way I can name it by the vertex is if it's a single one angle. Guys, if it's only one angle. If I give you a picture where you've got multiple angles, I cannot name it by the vertex. Are you with me? I cannot name it by the vertex if it has multiple angles, because then I won't know what you're talking about. Are you talking about this one? Are you talking about this one over here? Or the whole big angle? Are you following me? That's why you can only name it by its vertex if it's one angle by itself. You also can use a number given. If a number's in the center of your angle, I can name it. Remember what represents an angle? Kind of a slanted what? Kind of slanted L, half of a triangle, whatever. All right, and then that number. You've got to have the symbol for an angle so that I know you're talking about an angle measurement or an angle itself. All right, any questions? You will have to be naming angles today. Definition of an angle. An angle is formed by two non-collinear points not on the same line. Okay. Non-collinear points. Points not on the same line, right? You remember that? We talked about it. They're two rays, and they can't be the opposite rays. They have a common endpoint. So let's name this one. Help me name it. Angle DEF. All right, somebody else. Angle FED. Somebody else? Angle E and angle 1. Is that all right? So on your test, if I ask you to name it 4 different ways, you got it. Now again, only angle E is special. You can only do it if it's one angle. All right, example 1. Name the angle in 4 ways. Then identify its vertex and its size. So let's name it. Almost. Angle ABC, good. Angle. Nope. CBA. Right? The B has to be in the center. What's another one? Angle B. Angle 1. Make sure you got the angle in there. If you just say 1, it would be incorrect. Oops, sorry. We skipped a part. Now we want to name its vertex. Now, vertex is what? It's the point that connects them, and you said it is B, and you name it just like a point. It's not angle B because we're not talking about the angle. We're talking about the vertex, the point. All right, what's the size? And how do you label those? Okay, so we got AB, but we can't write it as AB. Why can we not? How do you name a ray? And you name a ray by what? BA, thank you, which is tricky, right? Comma, then you said BC. You got to name your arrays correctly. Endpoints first, even though it makes sense in your head, AB, right? But it won't work. It would be incorrect. All right, special case. Why is this a special case? It has 3 different rays that make up 3 different angles. Do you see the 3 different angles? All right, let's name all the angles having D as their vertex. I only want to name them one way. Angle ADC, that's the big one. Angle ADB and angle BDC. Now, why is there no angle 1? There's not a 1 there. Okay? Sometimes they have numbers, sometimes they don't. If they don't have numbers, then you can't name it by the number. All right, angle separates a plane into 3 parts. There's an interior, an exterior, and on the angle. So in example 3, where is point A located? Is it in the angle? Interior? Thank you. It's in the interior of the angle. Where's angle B? Everybody see that? On the outside of the angle. And angle C is on the angle. Is that okay? Now, sometimes they can get a little bit more involved and a little bit more crazy pictures. So just be careful, but that's the general gist. B's on the outside of the angle, where the 2 rays come together. That's the inside of the angle, and of course on it, you've got. When you measure an angle, this is called a protractor. And on a protractor, there's some in your little pocket. You'll have to grab one and use one. Now, if you don't have one at home, you're more than welcome to use mine. You can't check them out, but you're more than welcome to come in early and use those. What you do is you find your angle. So I had this angle right here. Okay? I find my angle. I want one of the sides to touch 0. Now notice here's an angle right here. One of the sides, that one right there, touches 0. There's 0 right there in that spot. And then you want to look to see where the other side touches a number. You want to start at 0, and they start at like 0 and 180. So you want to follow the side that starts at 0. And that's 60, 1, 2, 3, 4, 5, about 65 degrees. Okay. Now they could be facing the other way, and that's fine too. So again, this one may, there we go. So I've got my big O protractor. Remember, you want to line it up so this bottom ray is on the 0, right? However, I didn't mention that you want your vertex point in the center of the protractor. So I'm going to line up, whoops, I don't want to rotate it yet. I want to line up my protractor where the vertex point and the center are on top of each other. And I'm going to have to rotate it just a hair bit to, yeah, move in the other, thank you. To line up from 0 with one of my sides. And then I'll look at my line, and again, we're starting at 0. So I'm going on this outer side, looking at 0, and it's about 115 degrees. Make sure you give me the degree symbol, little circle on the top of the number. So the unit of measure and the actual unit. Make sure you give me. So let's do this one. Want to try? All right. So we're bringing it over here. We're lining up the center of the protractor. We may not have this slide. The center of the protractor. And one of the sides was 0. And then we look over here. 110. 1, 2, 3, 4. So 114. Now some people get confused. They look over here and they go, oh, it's about 65, 66. Right? Think about it. 114 is more than 90. My picture is more than a right angle, right? So it has to be going from 0 to 114. Just take your time. Line things up. A little harder to do in your book because my protractors are kind of large. Do the best you can. Acute angles are less than 90. Right angles are equal to 90. Obtuse angles are between 90 and 180. We talked about opposite rays. The rays go in opposite directions. They're also called straight angles. And those are 180 degrees. All right, let's classify this one. A, what kind of angle is it? Acute, right, or obtuse? Acute. Beautiful. All right, B. Obtuse. All right, and C? It's not right. It's acute again. I tried to trick you. Y'all get my humor. Awesome. All right, example 4. The measure of angle A is 100. Solve for x. What do? The angle itself measures what? 100 degrees. All right? But it also tells me the angle itself is 3x plus 10. Those are the same thing, right? Just said it differently. So if they're the same, you set them equal to each other. All right? Listen to it again. If things are the same thing, just written differently, you set them equal to each other. So 3x plus 10 is the same angle measurement as it is at 100 degrees. But I want to find x. So all I have to do is what? Subtract 10. I'm solving for x. Subtract 10 from both sides. 100 minus 10 is 90. Then do what? Everything gets divided by 3. 90 divided by 3 is 30. So x is 30. Why is x not 30 degrees? Good. It's not the angle. It's the variable. Very, very good. All right? I'm not going to really count off if you don't put degrees on that, but that's the correct thing. So be careful if you're taking the ACT. It might have 30 or maybe 30 degrees, and it's just the 30. It's just the variables. All right. Another word that you need to know is adjacent. Does anybody know what adjacent means?
Yes.
What? No, adjacent. Not adjacent angles. No. No. Nope. Normal word and adjacent. Like his house is adjacent to mine. Next to. Okay? His house is adjacent to mine, means it's next to. It's the very next house. All right? Adjacent. So when we talk about adjacent angles, it means the next angle. They're connected. They're right beside each other. All right? So here, we're talking about adjacent angles. There are angles that have a common side, so they share that side. They have the same vertex, which all angles should have the same vertex, and have no interior points in common. Okay, they don't overlap. They're just right next to each other. So angle 1 and angle 2 are adjacent angles. Angle, rewriting it a different way, JRM, and what other angles are adjacent? JRM, NRM. You could have done NRM or MRN. Either way. But those are adjacent angles, just written differently. So you're going to see it probably written more like this way in your book. When they say adjacent angles, you're going to have to look. Do they share a side? Good. All right. They share a common vertex? Good. That's important information. It's a star. Important. That's what you're going to see. That's all you do for that part. It wasn't it was just an example showing what it means. All right, so here, we're going to determine whether the angles are adjacent. Are angle 1 and angle 2 adjacent in A? Yes. They share a common vertex. What's adjacent mean? Next to. And adjacent angles means what? They have a common what? Vertex and a common side. Do they have a common side? Here's angle 2 sides. And here's angle 1 side. Do they share a side? Yeah. Where's the side they share? Because I colored them 2 different parts. They share a vertex, but no side. There's stuff over here and there's stuff over here. So no, they're across the street from each other. Or in your backyard, you know, but they're not adjacent, the very next side by side. All right, so this is a no. How about B? You said yes. Anybody disagree? Okay, so if I talk about angle 1.
Oh, sorry. I thought you were talking
about. No, angle 1 and angle 2. They share a common vertex and they share a common side. Yes. These are adjacent. They're also called a linear pair because they form a 180-degree angle. For later. How about C? No. Do they have a common vertex? No. Do they have a common side? No. So that's definitely a no. Excellent. All right. We talked about the angle addition postulate last class, remember? Add up the 2 smaller segments and get the, we talked about the segment addition, sorry. And we add up the 2 smaller segments and you get the larger segment. Remember that? Same thing with an angle. You add the 2 smaller angles together to get the bigger angle. Same concept, dealing with angles. So angle 1, whatever measurement it is, plus angle 2 gives me the angle of PQR, this whole big angle. All right, same concept. Dealing with the algebra, X's and Y's and all that stuff too, so beware. If the measure, and if it says the word if, that means it changes on each question. So don't assume once you've got an answer that you can use it again. All right, if it says if, you can't use that answer again. So if the measure of KNL, this right here, KNL, that's 110. And the measure of LNM is 25. What is the big angle?
135.
Right, so you're adding those together, and you get 135 what? Degrees. Make sure you've got it. Do you know what that little M is in front of these? It means the measure. Okay? Little m means measure. Question? Find the measure of angle 2. So we're looking for angle 2 in this picture. If the measure of angle 1 is 75, and the measure of ABC is 140. How'd you do it? Good. So she did 140 minus 75, and she got 65. What? Degrees. So that is the measure of angle 2. You can, but my final answer needs to have degrees. You don't have to. Like, a good question was, on your showing your work, do you have to use the degree symbol? No. I mean, it is fine. It's appropriate, but you don't have to. Just your final answer has to be in degrees. That's what I'm really looking for. All right, here's a harder one. You ready for a harder one? Find the measure of JKL, which is this angle right here. All right? And the measure of LKM, which is this other one, if the measure of JKM is 140. So this whole thing is 140. Huh. What do we know about angles?
There's 4x, and the LKM is 2x minus 10.
What do we know about two smaller angles and the larger angle? Huh? You might be right. Say it. These two angles are adjacent. The two smaller angles are adjacent. So they're side by side. They form the bigger angle. What do we say? What if I had two smaller segments and the big segment? What do we talk about them? They do what? If you add them together, they equal the same thing. So what about the two smaller angles and the big angle? What? What did we just talk about up here?
I think I'm going to be 104 because it's just in the
No. LJK is not 104. LJK is not 140 because 140 is the whole thing. Guys, how do you think about it? We just talked about it. What can you do with those two smaller segments?
divide them together. Put the two and divide it.
No division yet.
Put them together.
How do you put them together?
Like 2x minus 10 plus 4x equals 140.
Two smaller angles added together equal the larger angle as long as they're adjacent.
And then, like, you add the x's.
Add like terms. So 2x's and 4x's make how many x's?
And then you subtract 10 from both sides.
When I subtract 10, I'm going to add 10 because that's a minus 10, right?
And you divide it by 6.
Okay, then I'm going to divide it by 6. Now, if you don't remember what 6 is into 150, 6 goes into 15 how many times? 2, and that's 12. Subtract the 12 from 15, and you're left with 3. Bring down your 0. 6 goes into 30 how many times? A remainder of 0, so you know that your answer is 25. So that's x is 25, but that's not the answer, is it? Careful, because ACT is big on that. That would be one of your solutions. X is 25. Well, don't care. I want to find out what the angle JKL. So, no, it's not 140 minus 25. Why? JKL is equal to 4x. And 4 times 25 is 100. 100 what? 100 degrees. Then you want to go over and do angle LKN. Oh, this is nothing. It's going to get a lot worse. All right, so 25 times 2 is 50, minus the 10 is 40 what? Very good.
Wait, can you explain why?
Uh-huh.
So
That's angle. Okay, so in the actual homework and the problem, 2x minus 10 is that measurement. All right, so I took 2 times the x, which is 25. Multiply them together, that's 50. 50 minus the 10 gives me the 40. Are you sure? Anybody not get it? Want me to re-explain a piece? Yes. Top or where? Right here? This is correct. So the question is this first part correct? And it is correct. You have to have it in order to solve for the problem. So smaller segment plus, or smaller angle plus the other angle equals the big angle. Add them together, combine like terms, and solve for x. That's the algebra part. All right, once we've solved for x, we just substitute it back in. So we have 4 times the 25 that we just found, and that gives me the 100. And we have 2 times the 25 that we just found, and that gives me the 10. So if I add these together, I should get 140, right? 100 plus 40 is 140. So I know I did it correctly. 40? 2 times 25 minus 10. It's actually right here. That's the measurement for LKM.
Does it matter how you put it? Like, you know how it says like 4x, 2x, like that?
No.
Does it matter?
No. Not on addition. Not on this problem. Is that okay? Questions? Need another example?